Today is function operations, so I will dress appropriately.
Yeah.
Today we are math doctors because we're performing operations.
Oh, this is serious stuff.
It is serious because there are intricacies involved. It's not like we're going to take somebody's kidney out or something, but you know,
Looks like it.
there are intricacies involved with function operations. We are going to be putting things in to functions, just as if you had a patient and you were putting things into them. What you put into them would be very important. You would want to make sure that you got the right things out of them before you close them up. We've all heard those stories. Somebody finds out doctor left something in them. Well, our job is what goes into the function is incredibly important. We want to make sure we're picking the right stuff so good answers will come out. Here's our operations. Adding, subtracting, multiplying, and dividing. But maybe, just maybe, today before you leave, you might learn a new one. What do you say? Add, subtract, multiply, and divide. Isn't that all there is? No, it's not. And I might end up having to tease you until Tuesday because we might not make it that far.
Yeah.
We'll see. We'll see. We're going to add, subtract, multiply, and divide functions. Composition. Find the composite of two functions. Composition. So here's the deal. Anybody that has ever shopped for anything knows you got to watch for the sales. So this says you want to buy a sofa that's already been marked down by $100. Okay, that's a big break. The furniture store may add the 5% sales tax before applying that discount, or it may add the sales tax after giving you that additional discount. And if they say, hey, it's up to you, you want to know which one is going to be a better deal for you. So, which way is better for you, the customer? And how much better? So here's what we probably want to do with this, so we're not using a lot of variables to think through this. We want to start with a nice, easy, very expensive sofa. We're going to say our sofa costs $1,000. So we tell them, you know what, mark down that $100 first and then do the sales tax. So we start at $1,000, we take $100 off, and now we're down to $900. They figure out that 5% sales tax by taking 0.05, and we probably don't need to calculate this, but just so everybody can see it. 0.05 times 900. And get that 45 smackers. And 945 is what we get. So we bought the sofa, knowing it was $1,000, but also knowing we're going to get a $1,000 discount. Oh, there comes the sales tax, $945. So this is that discount first, then sales tax. So I start thinking, what if I don't think through it? Say, I don't care when you do the sales tax. You do the sales tax right now. You want to do that? Well, that's going to be 5% of $1,000. Do we need a calculator? How much is that going to be? Right. Then take your $100 off. It's your money. Take the $100 off first. Give me a lower taxable amount when I get done. This is better. That's what we would want to do. It was probably about 6-7 years ago now. You guys know the Albertville Outlet Mall? Been there before? Izod had a Black Friday special. In the window it said 70% off everything. And when you walked in, they handed you a little piece of paper that said, Because you're here for the early bird special, you get an additional 20% off everything. There are people walking around the store. 70, 20. We're getting 90% off. I was so proud of the little sales gal. She came up when they're saying that. She said it's not really 90% off. Because what we do is we take the 70% off and then you have a new price. And then we just take 20% off of that price. It's still a really good deal, but it's not 90% off. So it's our job as consumers to think through this stuff. If you get to choose, by golly, choose the right way. So the final cost of the sofa and the solvent involves two functions. One that gives an additional discount and one that multiplies to find the sales tax. So if you think through it, it makes sense that you want to tax a smaller amount. That would just make sense, but you have to think through it. And it's logic, and it's math. So on this page it says our essential understanding is we can perform those operations, add, subtract, multiply, and divide functions based on how you perform these operations for real numbers. One difference. We have to consider what we're putting in the functions. What are we putting in? Now, why do we have to consider that? Because we want real number solutions. That's what we want. Brings us to two issues. There's the first one. If we want real number solutions, can we just put any old number we want into the square root of x? Nope. X has to be greater than or equal to 0. What I just made is called a restriction on the domain. Right there. That's to guarantee that we get the answers that we want out of the function. We don't want imaginaries. We want real ones. Here's another one that's going to create havoc. What can't I use in there? So this is a new restriction on the domain. X can't be 0. Now it's not always just going to be 1 over x. It may be a situation where we see something like this. But we need to remember, hey, I can't divide by 0. If x is 3, that would be really bad. So I'll have to tell them, hey, x can't be 3. So those restrictions on the domain are part of performing those operations, of being the person in charge, being the doctor. So we're going to look at function operations. And you're going to find today we know all the math. We've added and subtracted and multiplied and divided and all this good stuff before. The key is we're going to add this little piece where we think through, is there anything we can't put in this? Is there something that would create a problem for real number solutions? So for addition, we're just saying if you want to add the two functions together, f plus g of x, you could just take them individually and add them and it'll work. You can do that. That's addition. If you want to subtract them, just take them individually and subtract them. Now that one does have us worrying about that most common mistake in mathematics. And that is, remember, if there's a negative in front of an entire function, we have to change all the signs in that function, not just the first one. Then we have multiplication. Yeah, take them individually, multiply them together. And division. Now this is the one where we start worrying the most about dividing by 0 is division. It doesn't mean it's not going to happen with the other functions. It might. But that's where we really have to start thinking of division. I can't divide by 0. The domains of the sum, difference, product, and quotient functions consist of the x values that are in the domains of both f and g. So here's what that means. We're going to start by looking at the function f and looking at the function g, and we're going to say, ooh, that has a fourth root in it. I've got to restrict the domain right away, because all I can do is x is greater than or equal to 0. Or, oh, that one's 1 over x. I can't use 0. So we immediately look at the functions and say, I can't use these numbers. I know that. Just going in to a surgery, I know I can't use those. And like it says, also the domain of the quotient function does not contain any x value for which g of x is 0. That's this piece right here. You can't divide by 0. So we think about all of that when we start, and we think about it all the way through the process. As we went through the process, did we have to take any even roots? New restriction on the domain. Did we do any division with x? New restriction on the domain. So this has got us adding and subtracting our functions, and it says let f of x be 4x plus 7 and g of x be the square root of x plus x. What are f plus g and f minus g, and what are their domains? Well, they want us to find f plus g and f minus g. And you'll notice they didn't put the x on these, and that's just notation. You know, even though the x isn't there, we can see there are x's inside these functions. So the notation is not a big deal. So before I start doing my addition, I'm thinking to myself, are there any numbers I can't use in f? See any square roots? Any division? Cool. So far the domain is all real numbers. But there's g. Go over to g. Do we have restrictions on the domain? Sure do. X is going to have to be greater than or equal to 0. So in the back of my mind, I know to start off with that is a restriction on the domain. Now, as I'm doing the math, if I have to take square roots, fourth roots, sixth roots, there might be a new restriction on the domain. If I have to divide by something, there might be a new restriction. So I'm constantly thinking, just like a surgeon would do, every move is important. What has happened here? All right, so f is 4x plus 7. G, square root of x plus x. I look at that. I put those parentheses there just to show you. This is f and this is g. They're not doing anything. They're not performing any operation for us. So we can go ahead and just drop them and think, well, how do you add with functions? You just combine like terms. That's all you do. So I would have a 4x plus an x, which is a 5x. I have a 7, but I don't have any other constants. And I have a square root of x. And I think about that step. In doing that step, did I have to take an even root? Did I suddenly have division pop up out of nowhere? Then the restriction that I knew right away is my restriction on the domain. Right there. Because nothing changed. You know, as we went through that operation, there wasn't anything new that popped up that would make something different happen. All right, f minus g. Already we know this. Maybe, just maybe, something else will pop up as we do this, but we already know from the beginning, hey, f, no restrictions, but g, yep, x has to be greater than or equal to 0. So now this is going to be 4x plus 7 as f minus the square root of x plus x. My parentheses are doing something. They're saying I'm going to take everything in the first set and I'm going to subtract the second, and we want to avoid the most common mistake in mathematics, which is missing a negative. So what we'll do is we'll drop the parentheses by distributing that negative. Remember, it's like a negative 1. That didn't give me any restrictions on the domain. So now, just as before, I changed it to adding a negative so I can just add it. So 4x and a negative x, that'll be 3x plus 7 minus the square root of x. Did I have to take any even roots or do division to make that happen? So we're back to x is greater than or equal to 0 because that was an original restriction. Again, it's that thinking about what did we put in to this function. All right, well, we have a couple more here, and I'm not even going to ask. I'm going to let you give these a try, and I want you to make use of those chicken wing elbow partners, especially if you're talking domain. Double check with people to see if there's any restrictions. Oh, I should tell you, if there aren't any, if you don't find any restrictions, you can just put our symbol for all real numbers, the R with the extra line on the left-hand side, or write out the words all real numbers. Let's see. Check in with somebody. 2 things you want to check for. Did you get the right answer when you did the addition and subtraction? But really the important one is going to be talking through the domain. Introduce yourself if you need to.
I'm Joe. Nice to meet you. Yeah, you. Also.
If there's square
No number.
How you doing? Feeling pretty solid about this? Did F have any restrictions on the domain originally? No. Some people were kind of thinking, and I hear people talking to their partners, squaring. Is that square root? No. No restrictions. You can square any number. We can do that and get real number answers. So then you go to x minus 3. There's nothing we can't put in there. So the domain for this one would be all reals. All reals. And then with our subtraction, 2x squared plus 8 minus x plus 3, so 2x squared minus x plus 11. What's the domain? All reals. You know, while we're doing this addition and subtraction, we never had to take an even root. We never had to divide by anything, so it's good. It's just all reals. And a lot of the problems that you'll see will just be all reals. But it's for those problems that have those even roots or have us dividing that we're supposed to be really extra careful about. So, multiplying and dividing functions. You know, the doctor antenna goes up and you think, wait a minute, if we're going to be doing division, I know there's going to be a restriction. If we're going to divide by x, there's going to be a restriction. But the first thing we do is we check them and see, do they have any restrictions to start off? How about x squared minus 9? Any numbers we couldn't use there? Okay, so we've got all reals. How about x plus 3? Anything we can't add 3 to? All good. What we're trying to do is see, would we ever get an imaginary solution out of that if we put real numbers into it? And no, those would be good. So f times g, with a little dot, will be x squared minus 9 times x plus 3. Well, that's just what all we have to do there. But as we do the FOIL, constantly be thinking, am I having to take any square roots, 4th roots, 6th roots? Am I doing any division? So x cubed plus 3x squared minus 9x minus 27. Did that change the domain? Not at all. No even roots showed up. Not dividing. But, like I said, we know this is an area where there is a problem. So we should be thinking in advance, okay, something's probably not going to be good here, so let's see. This would be x squared minus 9 over x plus 3. Oh, I'm going to stop right now and put my restriction on the domain. What number could a person not use in this form? At any time, if we can't use that number, we have to restrict the domain. But we're not done yet. Because it's possible that this x plus 3 might cancel out. How we'd find that is by factoring in the numerator. Because remember, canceling is a form of division. In order to divide, you have to see multiplication. They're inverses of each other. So x squared minus 9, oh, that's not a toughie. That's a nice difference of 2 squares problem right there. X plus 3 times x minus 3. And now we can definitely see that multiplication and know that these are going to cancel out. And our answer is x minus 3. Now, if somebody didn't know any better, and they looked at just the originals that we were given and said, hey, you can put whatever you want in there, and went down to the bottom here and looked at this one, hey, you can put whatever you want in there, they might try to use negative 3 in this formula. But this formula was not built for negative We know that because as we're doing the math, we see they're trying to divide by x plus 3. So this is the piece we have to be really careful with. Watching out for that domain as we go through. All right, now, I better check. I think we're okay for the got it. We just might not take composition today. Because we only have until 8:15. Yeah. Well, why don't you give this one a try? See if your factoring skills are a little unrusted. And when you're done, chicken wing and elbow partner. We have some stuck people on the division one, so I want to unstick them. But what's the domain for f times g? Everybody? For that first one you did, what's the domain? Yep, we're okay with everything here, okay with everything here. And there were no even roots that showed up as we went through there or any division. But obviously, there will be division with f over g. That first step is when you should stop and say, okay, if 3x plus 1 equals 0, I've got a problem. So 3x plus 1 equals 0, I'd have to subtract 1 and divide by 3. X can't be negative 1/3. Now that might not be the only one. There might be something else that shows up as we go through this. Now, generally, you can do a little educated cheat on this. So if you're having trouble factoring this, usually these problems are given to us because they want us to simplify. So I can try this. That's kind of an educated cheat. I could say probably they're going to want that to drop out. And then just think backwards. 3x times something has to give me 3x squared. That something would be x. And 1 times something has to give me negative 4. That something would be negative 4. Now, maybe they made this problem so we can't reduce it. So we should check with FOIL and make sure the middle term is gonna work. So we'd have 1x minus 12x, which is a negative 11x. And that way we're not wasting a lot of time doing the trial and error to try to find those numbers. It either works or it doesn't. In this case it did. So these will cancel out. Any new restrictions as we did that factor? So that's our domain right there. X cannot be negative 1/3. So like I said, incredibly important that at every step you're thinking, is there something that's happened here that's created a problem? And keeping track of it. All right, so we did add, subtract, multiply, and divide. We'll have to save composition for Monday. Well, that's all right. 4, 3, 2, 1, 0. How you feeling about add, subtract, multiply, and divide so far? Not too bad. Some of you a little rusty with the factoring, but good, good, good. And I'll double check, but I think I expect I was not going to get to the composition, so this probably does not have it.
What? I'm really hoping we get a candy.
You do a little sugar today?
Yep.
Yeah, there's no composition in here, so you'll be okay. Perform your operations, mathematics doctors.